Hello, hi, welcome everyone. Welcome back to my channel. Today we are doing surface area and volume of pyramids. Well, before that, I'm running GCSE batch classes, micro batch classes, very small. Like only 3 or 4 students are there. And if required, we make it 3 as well. And that too only £6 per hour. And if you are looking for any subject, for any year, just email us at exactacademy@gmail.com, and the charges are very minimal, it's affordable, and we provide classes from year 1 to year 13. And also, if you're looking for the mock papers, we provide them as well. And if you're looking for the free worksheets that are available at exactacademy.com. So let me start with this topic, pyramids. So let me first understand what is pyramid exactly. You can see this one, the figure here is pyramid, but let me have a closer look of this, which is this one. Actually, pyramid is a 3D figure in which there is a flat base and all the sides are triangular. Here you can see there is a base, and then all the sides, other side, like this, these all are triangles. So this is mandatory. Actually, all the sides are always triangle. But there are different types of pyramid, and pyramid gets their name on the basis of their base. Base, this one, this is the base. If the base is hexagon, then it's called hexagonal pyramid. Here you can see the base is a square, so this is a square pyramid. Similarly, if the base is pentagon, then it's called pentagonal pyramid. So we can see a pyramid is basically a 3D figure with a flat base surface having all the triangles as its side. Now, as I said, we are doing surface area and the volume of pyramids. So let me understand what is surface area. Surface area is the area of all the surfaces. Just like here, you can see there are 5 surfaces. This one, the bottom one, which is a square, and these 4 triangles, 1, 2, 3, and the front one, 4. Okay, if it's difficult to understand, let me clear it to you. See, this will lead to this triangle, your one triangle. This will lead to another triangle, that is second triangle. This will lead to third triangle, which is 3, and this will lead to the fourth triangle, which is this. So that's why it has 5 surfaces, and if we calculate the area of each surface and add them up, it will give us total surface area. From here, I can clearly understand that there is no particular formula, though there is a generalized formula which is definitely not in your syllabus and it's not even required. So it's better that we just have to find the surface, the areas of each surface, and then add them up. For a square base pyramid, calculate the area of the base, the square, and all 4 triangles, add them up, and similarly it goes with the other pyramids as well. So we can understand it much better with this example. It says find the total surface area of the following square pyramid. So they have given already the base is 15. Here the side is given as 15. Clearly it's mentioned, then it's a square pyramid. If it's a square pyramid, that means this is a square, and we know the area of a square. So I'm starting with surface area is sum of areas of all surfaces. So first we have to calculate area of the square. So we know the square is length times width, and length and width both are same. So it's going to be 15 times 15, which is 225 centimeters squared. Now, all the other triangles are same. So if you'll be able to calculate one triangle, just multiply it with 4 to get the other triangle. Why? Because they have the same height and same base. So area of each triangle will be half times base times height. Here, half times base, as we know, is 15. Why? Because it's a square. So all sides are equal for a square. So half times base times height, which is mentioned here as 30. So this is again 225 centimeters squared. So total surface area would be, final is 225 plus 225, which is 450 centimeter squared. So this is how we can calculate the total surface area of a pyramid. Moving on to the next question. It's given as the total surface area of a regular tetrahedron is 16 root 3 centimeters squared. See, first of all, the most important thing is you should know what is a tetrahedron. Tetrahedron is also a pyramid having the base as a triangle. So you can clearly see it has 4 surfaces. This base, this is at the bottom actually. So this bottom one has a triangular surface. Similarly, it has 3 sides because this side will lead to this triangle. This side will lead to this triangle. And this side will lead to this front triangle. So basically you have 4 surfaces, and what's important thing mentioned here is it's a regular tetrahedron. Wherever the regular word is used, that means all the sides are equal. So regular tetrahedron means all the sides are equal. So it's mentioned that if it's A, then this is going to be A, this one A, this is A, this is A, this is A. That's the meaning of a regular tetrahedron. All the sides are same. So we have to calculate area of each triangle. So if you'll be able to calculate area of just one triangle, you can easily calculate the area of other. Just multiply by 4 and you'll get the total surface area. Now each side is equal. That means all the triangles are equilateral triangle. So area of each triangle is area of each triangle. Let's see what these triangles are. These are equilateral triangles, that you have to understand it. There is a direct formula. I'm just using the formula, or you can use by dissecting this, or by bisecting this into 2 equal halves like this. But there is a direct formula that I'm using right now, which is root 3 over 4a squared. This is the area of one triangle. Then the total surface area would be root 3 over 4a squared times 4, because there are 4 surfaces. So we'll get answer as root 3a squared. And this is given as 16 root 3. So a squared is equals to 16, and a is equals to plus minus 4. But since a length can never be negative, so it's 4 centimeter would be a. So in this way, we can calculate the length of each tetrahedron as 4 centimeters. The next is the volume of pyramid. Volume is basically the total space covered by any 3D object. That's called its volume. So you can clearly see this is a tetrahedron given because its base is a triangle. So there is a general formula, obviously, which is the volume of pyramid is 1 over 3 times b times height. Now you have to understand what b stands for and what height stands for. Why? Because we know there are different types of pyramids. So obviously there will be a difference in formula every time. This is a generalized one, but b stands for area of the base. And we know that every pyramid has a different base. I mean, if I'm categorizing each pyramid, so we have categorized on the basis of their base. So the area of the square base would be different. The area of the pentagon base would be different. That's why there is a general formula written that is 1 over 3 times b times h. H stands for height of the pyramid, and B stands for area of the base. Now let me see one question. It says calculate the volume of a pyramid given in this figure 1. So we know, we just study the formula to calculate volume of pyramid, which is 1 over 3 times base times height. B, that means area of base. So base stands for area of square here, and that is 6 times 6. We know length times width. 6 times 6, that is 36 centimeters squared would be the area. Height is already mentioned as 5. So volume is finally 1 over 3 times 36 times height, which is 5. This will give you 60 centimeter cubed as the volume of this pyramid. Let me do one more question. The volume of a given hexagonal pyramid is 144 centimeter cubed. If the height of the pyramid is 6 root 3 centimeters, find each of the base, which is a regular hexagon. Find the length of basically each of the base, and the base is a regular hexagon. So we know that the volume of a pyramid is 1 over 3 area of base times height. 1 over 3 area of base times height. We already have the volume, which is given as 144. 1 over 3 times area of base, we are not aware of it, but we do know the height, which is 6 root 3. From here, the base would be, I can say 144 and can cancel out this one. So I'll get 2 root 3b. And from here, b would be 72 root 3. I have divided both the sides by 2 over root 3. 72 over root 3. So when I divided both the sides by 2 root 3, I got this answer. Now, base is 72 over root 3. We know that this is a hexagon. If I say, let me draw a hexagon, this one. This is a regular hexagon. And so let's say each side of this regular hexagon be A. So this can be easily divided into 6 equilateral triangles. Keep that in mind. A regular hexagon can be divided into 6 regular equilateral triangles. So we just know that area of an equilateral triangle is root 3 over 4a squared. So then area of all the 6 would be root 3 over 4a squared times 6. That will give you 3 root 3a squared over 2. That's the area of hexagon. And now base is what? B is what? Area of the hexagon. So we know now that area of the hexagon is 3 root 3a squared by 2, and also it's 72 over root 3. So let me equate it. 3 root 3 over 2 a squared is equals to 72 over root 3. Cross multiplying, that means it will go up there, it will go up there. I'll get 9 a squared is equals to 144, and a squared is equals to 144 over 9. Take the root, so a would be 12 over 3, which will give you 4 centimeters as the answer. That means each side of this regular hexagon is 4 centimeters. So basically that's it for today. I have just covered the basics of surface area and volume of the pyramids. It was to give you an idea how we can approach these questions, and in the next class we'll be doing the sheets, where I'll be doing some simple as well as some harder questions and the type of questions that you can expect to come in the exam. So that's it for today. Thank you. Have a great day.